Hey everyone, and welcome to this explainer. Today, we're setting out on a seriously fascinating and high-stakes journey into the world of UV flatbed printing. You know, if you've ever marveled at the incredibly crisp graphics on a piece of rigid acrylic, or maybe a custom wooden sign, you're actually looking at the end result of an incredibly precise process. But getting to that flawless final product, well, it's a bit of a tightrope walk. We're going to break down the science, the exact mechanical calibrations, and the hidden chemical traps that can totally make or break your production run. Okay, let's dive into this. What turns a flawless UV print into an absolute machine disaster? Because mastering UV printing isn't just about buying an expensive piece of machinery and hitting the print button. No way. It's about deeply understanding the complex, almost microscopic environment that the printer operates in. The variables here are incredibly tight. I mean, a fraction of a millimeter or just a slight bounce of stray light can literally be the difference between a pristine output and a completely destroyed printhead. Section 1. Mechanics of UV printing. The invisible magic of curing. So the moment the ink leaves the machine, this completely fascinating mechanism takes over. The printhead deposits these microscopic droplets of UV curable ink right onto the substrate. But unlike traditional inks that dry through evaporation over a long period of time, this ink contains special chemicals. They're called photoinitiators. And the moment the UV LED light passes over those droplets, it triggers a rapid chemical reaction called photopolymerization. Basically, the ink cures and hardens instantly, right there at room temperature. It's an amazing process for sure, but it relies on a very strictly controlled physical space, which we call the printing distance. Take a look at this microscopic view of the word resolution printed cleanly on fabric. Achieving this level of crispness, it's a really delicate balance. If your printing distance, the gap between the printhead and the substrate, is even slightly too great, you're going to run into major issues. See, the printhead moves incredibly fast, and that horizontal movement creates tiny air currents. If the drop has to travel just a bit too far through the air, those currents will actually blow the microscopic ink droplets right off course, and what you get is fuzzy, blurry text instead of the razor-sharp edges you're seeing right here. Section 2. Conquering tricky substrates, wood and mirror acrylic. Now, untreated raw wood is widely considered the arch nemesis of UV printing. Why? Well, because natural wood has this loose, highly porous fiber structure. If you try to print directly onto raw wood, it acts exactly like a sponge. The wood just absorbs and diffuses the ink deep into its fibers way before the UV light even gets a chance to cure it. The result is this faded, smudged, bleeding image. It's a mess. So the absolutely crucial takeaway here is that you must seal the surface first. Applying a clear varnish or primer blocks those pores, giving the ink a nice smooth surface to sit on so it can be instantly dried by the UV lamp. Now let's talk about mirror acrylic, because it poses a really unique physics problem. You have an intense UV light shining down on a highly reflective surface, and that mirror finish, it actually bounces the UV rays straight back up into the printhead. This can prematurely cure the ink right inside your nozzles, which is a total nightmare. If you're just doing occasional jobs, you have to be meticulous, really meticulous, about cleaning the printheads before and after. But for high-volume jobs, you literally need to install an extended bracket to move the UV lamp further away. This creates a tiny time delay so the ink fully exits the nozzle before the light hits. You can also lay down a clear primer or even use a black cloth buffer to absorb all that stray light. Section 3. The art of adhesion. Primers, promoters, and preparation. Preparation is absolutely key to your survival in this process. You have to manage both the physical and the chemical variables. Physically, lightweight or bent materials are going to shift around, so they must be taped completely flat to the bed. Chemically, for tricky non-porous surfaces, think coated metals, rubber, or thin plastics, you need to wipe on a thin, even coat of a low-odor adhesion promoter using a lint-free cloth. For really sensitive thin acrylics, you can actually dilute that promoter with 70% isopropyl alcohol so it doesn't damage the surface. And here's a pro tip. Sometimes just hitting the material with a heat gun prior to printing alters the surface energy just enough to make that ink bind flawlessly. Section 4. Perfecting bed leveling, where millimeters matter. So, the whole point here is maintaining an absolutely uniform distance between the print nozzles and your media. If your bed isn't level, your print thickness is going to be wildly inconsistent. Manual leveling requires turning off the machine, thoroughly cleaning the bed, and then using a precision tool called a feeler gauge at the four corners and the center. You adjust the bed screws until you have a perfectly uniform distance, usually right around 1 to 2 millimeters, depending on your specific manufacturer. And remember, environmental factors like temperature and humidity can actually warp your printer bed over time. So this isn't just a one-and-done task, it's a routine necessity.
Section 5. Preventing costly head strikes. The ultimate machine disaster.
Okay, things are getting a bit higher stakes now. A head strike is exactly what it sounds like, any event where the print heads physically crash into the media. To put this in perspective, on many UV cure printers, the standard distance between the media and the print heads is a microscopic 0.085 inches. That's incredibly close. That means if your rigid media isn't perfectly flat, or if the heat of the printing process causes a thin material to bow upward even a fraction of an inch, your high-speed carriage is going to violently slam right into it. So, look at this cross-section. On the left, we've got a perfectly clean print head profile. But look over at the right. The physical scraping of the head against the media doesn't just damage the metal on the outside. It literally shoves partially UV-exposed ink and media dust backward, right up into the nozzle orifices. Inside that nozzle, this partially cured ink meets unexposed liquid ink, and it instantly binds with it. This initiates a chain reaction that cures the ink entirely inside the printhead, creating a permanent, fatal blockage. It's pretty much game over for that head. Now, if you suspect you've had a head strike, even just a slight graze, you have to clean the heads immediately. But how do you know if permanent damage is already done? Well, you run a diagnostic print test, like a manual jet mapping pattern. Look closely at jet 62 and 77 on this test. See those wavy lines? That is the telltale sign of an intermittent jet. It means a microscopic solid particle of cured ink or media is permanently lodged inside the nozzle, occasionally blocking the drop or knocking it sideways. Those wavy lines mean you have lasting damage that needs to be digitally mapped out of your entire system.
Section 6. Troubleshooting UV ink cures. Rapid Recovery Guidelines.
This matrix right here, which uses data from the Screen Printing Technical Foundation, is an absolute lifesaver to have pinned up near your machine. If your ink simply isn't curing, the solution might be as easy as reducing the dryer belt speed, or maybe checking if your UV lamps have aged and lost their power. On the flip side, if the ink is curing but the edges are chipping during die cutting, your ink might be over-cured. So you actually need to increase the belt speed, or maybe you need to formulate a softer ink entirely. And if the ink is gelling in the container before you even print with it, it means it was exposed to stray light or excessive heat in storage. You should always rotate your inventory using first in, first out. So, to sum up our ultimate conclusion here, in UV printing, a millimeter of preparation saves a mile of ruined prints. I think that pretty much hits the nail on the head. From taping down your materials, to meticulously leveling the bed with a feeler gauge, to ensuring your UV lamps are at the correct distance and power. Patience during setup is literally the only way to protect your machine and guarantee a flawless result every time. So, I want to leave you with this question to think about. The next time you walk up to your flatbed, will you take the time to conquer these microscopic variables, or will you let the arch nemesis of unprepared surfaces completely ruin your next big job? The choice is entirely in your hands and, honestly, in your preparation. Thanks so much for joining me on this explainer, and hey, happy printing!